Try not to be too gross on this recording. Hello, everybody at home. All right, logarithms, day 2. So there are two rules with logs that come up a lot. And I'm going to write it like this. This is a rule with logarithms. Did you guys see how these have the same bases? And you realize that the base isn't actually base B, but there's like a number there, right? And it's the same number here and here. They're both like 3s or something like that. So there's a rule with logs where you can combine them and write this is log base B of x divided by y. So if there's a subtraction sign here, then you can put them together in one log and have those two divided by each other. Similar rule here, if you have the same bases, you can put the insides together. Oh, hey, if you are watching this online because you are at home and you are quarantined, reach out to somebody in class today and ask them what's going on with the final, because things have changed quite a bit. That sounded scary. It's generally good news, but, you know, be a little frightened. It is not, that's not what's happening. Okay, so basically if there's a addition between the logs, you can combine them together by multiplying, and if there's a subtraction between the logs, you can combine them together by dividing. I don't have a great reason why this is true. It's just a rule that I've memorized for logs and exponential functions. Well, I guess I do have a reason why it's true. Okay, I know why it's true, and here's why. Do you remember if you had, like, let's say we had 3 squared times 3 to the 5th. What did that make when you multiply them together?
3 to the 7th.
3 to the 7th. Remember that you add the exponents?
Yeah.
When you're multiplying the bases, like x squared times x to the 5th makes x to the 7th. So that makes sense because here we're multiplying, and then to put them together we add. And remember, exponents are the exact opposite of logs, so when you're adding logs, when you put them together, you multiply. It makes sense in the sense that they're inverses of each other. Same thing here, if I had 3 to the 5th over 3 squared, if I combine those together, I'd get 3 to the 3rd, right? Because I'd have 5 3s on the top, 2 3s on the bottom, you'd cancel them out, you'd have 3 left. So if you divide, then you end up subtracting in there. If you subtract here, you end up dividing there. So they're opposites of each other. Okay, so now let's move to the worksheet. I've circled the ones you have to do, which is every other one. And check it out, I even got smart. Are you ready to see how smart I am? Everybody ready to be impressed?
Yeah.
On the first sheet, you see how I did 1, 4, 5, right? And then on the second one, I got y's and decided to do 2 and 3. That way you don't even have to say number 3 on the second sheet, because we're only doing one number 3. What? I know. Not smart enough to know it right from the beginning. Circled one, crossed it out, and then I made the connection. Did I even, like, bother getting a new sheet and acting like I was smart enough in the first place? Not at all. Okay? Like, just left it as it was. Okay, so you have to do all the circled ones, and you're going to have the whole hour to work on this today, except for I'm going to help you start. So, let's start with, how about there are 26 total problems. Let's start with number 12. Let's do number 12 together. Which number 12? The only number 12. Thank you. So, what do you think we should do first? Add the 5. Everybody with me? Add the 5. We've got 11 to the n minus 8 equals 59. Okay, now what? We've got an n in the exponent. What do we do? Log base 11 on both sides. Now I've got n minus 8 equals, in your calculator, you need to do log of 59 divided by log 11. Go ahead. I want to see everybody doing it. You get about 1.7?
Yeah.
Then what?
And you have to
Add 8, n equals 9.7. This is very similar to what we did yesterday, right? Not so bad. Exactly what we did yesterday, just kind of reinforcing these ideas. All right, let's jump to something a little harder. Let's jump to number 24. Yikes. Let's be honest. Before yesterday, would you have any clue how to solve number 24?
No.
Anybody? Anybody remembering this stuff from Thorson? Okay. Did you solve problems like this with Thorson, or did you just go over like the basics of logarithms?
That's all.
Basics? No idea. Okay. All right, now what? Tell me about 24.
Subtract or add them 6 each side.
Add 6 to both sides. Everybody with me now. Negative 10 e to the 2 minus 2b equals negative 60. And then?
And then we're going to divide by negative 10.
Divide by negative 10. Let's not pay thousands of dollars for an extra class of college when we can learn how to do this now. Ooh, how do you get rid of an e? Natural log. Log naturel. It sounds very French. Natural log of 6. I got 1.792. Now what?
Subtract 2.
Subtract 2. Remember opposite PEMDAS to solve this stuff. That's negative 2b. 1.792 minus 2 is negative 0.208. And then what?
Divide by 2.
Divide by negative 2. Divide by negative 2. B equals almost 1. 1.04. Duh. So did that on, yep,
I missed what you did when so you do the natural log on both sides,
yep.
and then, so is it just the natural log of negative 60?
Yeah, so the natural log of 6 is that.
Oh, I forgot.
Okay, now this first stuff is stuff that I'm just kind of trying to reinforce what I taught you yesterday. And the second page is all brand new things. Anybody have any questions to me about number 24? Caitlin, it looks like you almost have a question. No? Okay. All right. We're going to do number 3. All right. Now, yesterday we learned how to take care of something that was in an exponent, right? Because the opposite of an exponent is a logarithm. And the opposite of a log is a exponent. Okay, so what is the automatic base when they don't write a base? 10. Here's how I'm going to get rid of both sides. Do you remember how an exponent gets rid of a logarithm? I'm going to put a base 10 on both sides, as in like this is 10 to the power of all of this stuff, and that's 10 to the power of all this stuff. These cancel out because I'm doing the same thing on both sides. Notice I can't have one that's like log of 6 and one that's log of 4. They both have to be the same. And I'm left with 4p minus 2 equals negative 5p plus 5. Now what?
Subtract the 4p and subtract the 5.
Okay, looks like Kyle's decided to get the p's on the right. So now I've got negative 2 equals negative 9p plus 5. You said subtract 5 as well. That's negative 7 equals negative 9p. Am I going too fast?
Almost.
Okay, divide by negative 9. You should get what? 7/9?
Yeah.
0.777? Or 778?
Why'd you put the 10 like by the 4 and then write another 10?
So it's kind of like I'm doing a move to get rid of the logs on both sides. So I did a base 10 on both sides to get rid of them. I think it's easier to understand if we move on to number 10, and I'm just doing it to one side, and you'll kind of understand. Okay? So let's move on to number 10. We can go back to number 3 and talk about it. Yes?
Can you look at number 2 quick though?
What?
Number 2, how do you solve that? Number 10.
Exactly the same way.
Yeah, but it's 10 minus 10. So it equals 0?
You can, yeah?
Oh.
Okay. But, okay, Kyle, I know. Kyle, look at me. Look at me right in the eyes. Okay?
Yes.
You are notorious for wanting to save time with things and then confusing yourself for wanting to save time with things, right?
Yeah.
Do not be doing the rest of this worksheet while I'm trying to teach you something.
I'm not.
Right. Mister, let's talk about number 2.
Oh, Kyle.
Well, I just was looking
You're just taking a look, just taking a quick look. I mean, like, who knows? Maybe we could just get this worksheet done in a second. Who knows?
Okay.
Okay, talk to me about number 10. What do you think we should do first?
We could subtract the x minus 3.
No, this is like log base 3 of this. This is